So this is a pop quiz 9 I'm discussing. The first one answer was A because the metal carbonate react with acid. It will give carbon dioxide and salt, water, and carbon dioxide. And we discussed this as well. First, it will be a precipitate of a calcium hydroxide, and then it's a barium carbonate because of carbon dioxide is bubbled through a solution. So this question quickly we will do. So whenever we want to balance a redox equation, so it was chlorine turned into chloride ion, that is one, and the chlorine has turned into the chlorate ion. What we did is first we balance these, we separate the oxidation and the reduction half equation, and then we balance. So we put 2 for balancing the chlorine, and we also put 2 here for balancing the chlorine first, and then we add water molecules to add to make the oxygen balance, and then we balance the protons by adding then we balance the hydrogen by adding a proton, and at the last we were adding the electrons. 10 electrons were added so that the charge is also balanced. When we want to combine these two equations, we have to make the number of electrons same. So when we want to make number of electrons same, this was 10 electrons plus 5Cl2 plus 10Cl minus, and this was 6 water molecules plus Cl2 gives 2ClO3 with a charge -1 and 12 protons plus 10 electrons. When we add these two equations, electron cancel with electrons, it's on opposite side. We have 6 water molecules, we have 6 chlorine, we have 10 chloride ions, we have 2 chlorate ions, and we have 12 protons. Now we want to convert this into alkaline medium. So if you want to convert into alkaline medium, you add OH. How many OH ions you will add both sides? You will add same as the number of protons. So you will add 12 here as there are 12 protons. And this 6 water molecules here, and this will be 12 water molecules. If you move other side, if you move this to other side, what you're left with, it will be 12 OH ions plus 6 Cl2 gives 10 Cl minus plus 2 ClO3 minus 1 plus 12 water molecules. And these 12 water molecules and 6 water molecules are moved other side. So this will become 12 minus 6, which is also 6H2O. Now, this is the equation, final equation, but the final equation should be in a simplest ratio. This equation is not in a simplest ratio, as you can see. As you can see, all of them are divisible by 2. All the numbers can be divided by 2, so we can further simplify. So it means of what will the final equation if I divide each number by 2, as all are divisible by 2, because chemical equation should always be in a simplest ratio. So this will be 6OH minus, and this will be 3Cl2 gives 5Cl minus plus ClO3 with a charge -1 plus 3H2O. So this is our final equation. Now we'll compare the coefficients. It will not take, when you are in practice, it will not take too much time. So multiple equations, when you practice a similar question, you will get used to how to balance these type of equations. So how many Cl, what is the coefficient with Cl2? What is the coefficient with Cl2? 3. So it means either, because this V is there, so either B can be an answer or C can be an answer. Then what is the coefficient with X is a chloride. So what is the coefficient of the chloride? The coefficient of the chloride is 5. So it means this is 5. And what is the coefficient of the chlorate, which is 1 here for us? So 1. So it means C will be the right answer for this equation. Is it clear, this question? Any doubt in this? Okay. Question 4, any doubt? Question 4? Question 4 or question 5, 6? Question 4? Okay. In question 4, the properties of a chlorine, bromine, and their compounds are compared. So, which property is smaller for chlorine than for bromine? The bond strength for a hydrogen halide. For example, if we compare the bond strength of hydrogen with chlorine and hydrogen with bromine. So, as we know, as we go down, the bond strength is decreased, it becomes easy to break the bond. So, as a result, HBr bond we can break because HB bromine is having a larger size, so weaker strength of a bond, so it can easily break down. So it means HCl bond will be stronger and this will be weak. So it cannot be A. First, ionization energy. Ionization energy, when energy needed to remove electron. So if we compare, because the chlorine is having smaller size and the bromine is having a larger size, so as a result, when the size increases, what will happen to ionization energy? It will decrease. So the first ionization of chlorine will be greater, but bromine will be smaller. So it cannot be B as well. The solubility of a silver halide with ammonia. So as we go down the group, the solubility increases. Like if we have silver chloride is there, and we have silver bromide is there, and we have silver iodide. So when we go down the group, what will happen? The solubility of these halide increases. They become, yes, sorry, solubility in aqueous ammonia. Yes, right, Mira. The solubility in aqueous ammonia is decreasing, right? Because if we compare the solubility, that if we have AgCl, we have AgBr, and we have AgI. So if we add dilute aqueous ammonia, this will dissolve, this will not dissolve, this will not dissolve. But if we add concentrated aqueous ammonia, this will dissolve, and this will not dissolve. So as we go down the group, the solubility decreases. Like this will be less soluble and this will be more soluble. So means silver chloride will be more soluble and silver iodide is less soluble as it does not dissolve. So it cannot be C because we want a smaller property for a chlorine than for bromine. Then strength of a van der Waals force between the molecules. The van der Waals force depends on the number of electron. Because in a chlorine molecule will have less electron as compared to bromine molecule. Both are like non-polar molecules. As they have more electrons, a stronger van der Waals force will be there. So if we compare the van der Waals force, it means the chlorine will have a small van der Waals force as compared to a bromine which will have a large van der Waals force. So D will be the right answer. Is it clear? So the van der Waals force is increasing. Like if we have a two chlorine molecules, they will have weak van der Waals force as compared to two bromine molecules. And what is the reason for that? Because this will have more electrons in the structure, in the molecule. This is having few electrons in the structure. So if we have more electrons, stronger van der Waals force. If we have few electrons in the structure, weaker van der Waals force. Question 5 or 6, any doubt? So for question 5, A is the answer. Question 6, C is the right answer. Question 7, 8, any doubt? Question 7, 8. Question 8. In question 8, the structural isomers and the stereoisomers should be considered when answering this question. So we should consider how many structural isomers are possible. And actually, both we have to consider how many isomers with the formula C5H10 have a structure that involve a pi bond. So when they said a pi bond is involved, it means a carbon-carbon double bond should be there, because for alkenes, one of the isomer is the cyclic alkene, but cyclic alkene does not contain a pi bond. That's why we cannot have a cyclic alkene. So we cannot select a cyclic alkane other than a cyclic alkane. We can select any of them. Now for this one, you can simply draw the structures and identify. First, what we do, we change the position of a double bond, because we have C5H10, which is pentene. So in a pentene, we'll have 1, 2, 3, 4, 5. And at the same time, you can check whether the geometrical isomer exists or no. How you can identify if a geometrical isomer exists or no? If identical groups are attached, like example, with a carbon-carbon double bond, uh, there's a two hydrogens are attached, so this does not have geometrical isomer. So it means this will have only the structural isomer, but this will not have a geometrical isomer. So this is one. How I identify it cannot have a geometrical isomer, because two hydrogens are there. When carbon-carbon double bond, if a carbon is surrounded by the identical groups, it cannot have a geometrical isomer. That's why this is impossible to have a geometrical isomer. So only one possibility is there for this one. Now what we do, we change the position of a double bond. So this will be CH2, then CH, double bond CH, then CH2, and then CH3. So this was pentene. This is pent-2-ene, but this pent-2-ene, two possibilities are there. What are the two possibilities? That this can have a geometrical isomer. How this can have a geometrical isomer? This will be CH3, sorry. I mentioned CH3, CH, CH, CH2, CH3, pentene, pent-2-ene. This pent-2-ene can have the two geometrical isomers cis and trans. How we identify it can have a geometrical isomer? Because the carbon which is having a double bond is having two different groups attached. And same thing, the other carbon is also having two different groups attached. So means how many now possible isomers we mentioned? We mentioned total three of them, because cis pent-2-ene and trans pent-2-ene. Because in a pent-2-ene, it can be cis or it can be trans. Now, if I move the double bond, why the first one cannot have a geometrical isomer? Just recall the idea of the geometrical isomer, that when identical groups are attached, this is how the first structure will look like. When identical groups are attached, so it is impossible to have a geometrical isomer, as we cannot distinguish between the two atoms which are attached. Here, this carbon-carbon double bond, so two hydrogens, identical groups are attached, so it cannot have a geometrical isomer. Clear? Because the identical groups are attached. To be a geometrical isomer, two different groups should be attached to a carbon which are having a double bond. For the second one, as you can see, you want me to draw the geometrical isomer, like these are the two carbon atoms which are having a double bond. So this is one, this is the second. So two carbon atoms which are having a double bond. One is hydrogen attached to that. Another one is CH3 attached. Same thing, one is hydrogen attached. Another is CH2 and CH3 group is attached. So when you compare, this is a heavy group, and when you compare this a heavy group, so this will be the Z. This will be Z-pentuene because the heavy groups are attached on the same side. And the other way I can draw a geometrical isomer, like I can draw CH2, CH3 up, CH2, CH3 up, and hydrogen down. So what is this? This will be E-pentuene because the heavy groups are attached on the opposite side. Is it clear? Now, if we move the double bond to more towards right, that will not make any difference. Like if I draw CH3, CH2, CH, double bond CH, and then CH3. This is same structure. This does not make difference because this is pentuene, this is also pentuene. So means I cannot further move the double bond. Now, next what we can do in an alkene, now we can make branches. So we'll start making a branches. And how to make a branch? Like we'll keep the double bond with the first two carbon atoms. So it will be CH2 double bond CH, and we have best way is like just change the structure of the carbon. So C double bonded with C, four carbon atoms are there, and one is a branch. So this will be CH2, this will be CH3, this is not having any hydrogen, this will be CH2, and this will be CH3. So this is what? This is 2-methyl because second position CH3 group is attached. So this is 2-methyl butene. This is one. Now we check, can a geometrical isomer, this is normally like example, this is pentene, this is pentuene, which can be cis or trans. This is second position, we have a methyl group, so 2-methyl, and 4 carbon atoms are there, so it is butene. So it is 2-methyl butene. And can this have a geometrical isomer? So again, whenever you want to see a geometrical isomer, the two carbon which are having a double bond, if the identical group is attached, like hydrogen is attached, so it is impossible that this can have a geometrical isomer. So there is no geometrical isomer for this one. Then we'll change the position of a branch. The double bond is there already with the first carbon. Not both have CH2. Any one of the carbon is identical because the C double bonded with C, two hydrogens are attached. So identical groups are attached to a carbon which is having a double bond. That's why it cannot. We don't bother about the other carbon. If one of the carbon is not having, it's having the identical groups attached, so it cannot have a geometrical isomer. Then what we do, we just change the position of a branch. We just change the position. Now a branch is with the third carbon. So this will have CH2, this will be CH, this will be CH, this will be CH3, and this is also CH3. What is the name of this compound? Branch cannot be attached with the first or the last carbon. Branch is always from second to second last carbon. Because when you attach with the first or the last carbon, this is not count as a branch. So what is the name of this compound? Third position, we have a methyl group. So this is 3-methyl and but because of 4 carbon and ene because of the double bond. So how many isomers till now we have drew? We have drew 4. Now what we do, we move the double bond and make a double bond with the second carbon and make a branch. Why we cannot count from the, won't be 2 since we consider, no, whenever, look, counting start from a nearest functional group. When we count, when we give a priority, double bond with the first carbon. And so that's why we start counting from the double bond. We don't count from the right hand side. If I count from the right, the branch is coming at second carbon. But if I count from left, the functional group is coming from the first carbon. So we always give priority to the functional group. That's why we are counting from the left hand side. So this is 3-methyl butene. Now we change the position of a double bond. We make it to second and the branch. So branch will be here. So this will be CH3, this will be CH3, this will be CH, and this will be CH3. Now, is it clear? So now what about this one? Can it have a geometrical isomer? The answer is no. Why? Because this is a carbon which is having a double bond. Both, it is surrounded by CH3 groups. When identical groups are surrounding, this cannot be a geometrical isomer. It can have structural but not geometrical. To be geometrical, the carbon should be attached with two different groups. The carbon-carbon double bond attached with the two different groups. So what is the name of this compound? We select the longest carbon chain. Numbering should start from nearest double bond. So 1, 2, 3, 4. Or we start, so both cases, so it is 2-methyl. Second position, we have a methyl group. And 4 carbon atoms are there. It is but, and then it is 2-ene. Where is H2? Which one? We have 3 hydrogens here, 1 hydrogen here, 3 hydrogens here, and 3 hydrogen here. So 3, 6, 9, and total should be 10, as we want C5 and H10. This cannot be geometrical isomer. Why this cannot be geometrical isomer? Because as you can see, the carbon-carbon double bond, it is bonded with CH3 identical groups. This is CH3, this is also CH3. So because the identical groups are attached to a carbon-carbon double bond, so it cannot have a geometrical isomer. Because it should be a different group attached. And if I change the position, like it won't make any difference to. So it won't make any difference. Like example, what if I draw another structure like this and CH3 on this one? It will not make difference. It's actually the same structure. Now what we do, the last one, because we can have three in the straight chain and 2 of them. So as we attach this, so if we try to attach, like how many are there? This is pentene is there. Then this is cis and trans pentene is there. 2-methyl butene is there. 3-methyl butene is there. And 2-methyl but2-ene is there. Is it clear? This one? Because if I make 3 and I try to make a branch for this, so it is the same structure. It does not make any difference. Because I cannot make a branch at the center with a double bond. Why we cannot make a branch? Look, when I try to make a branch with this one, so carbon maximum can form 4 bonds. So this is 1, 2, 3, and 4 bonds are already formed. So I cannot make a branch with 3 carbon atoms because it's the same thing. If I select the longest carbon chain, so this is the same structure as 2-methyl but2-ene, which we do here. Because it cannot have a branch, the 3 carbons cannot have a branch up, as we have to draw 5 carbon atoms. That's why it is not possible. Like ene branch to third. If you want to draw a branch with the third one, it's not possible, as C double bonded with C. What you're saying is, if I draw a branch with this one, the branch cannot be attached with the last carbon atom. The branch is always with the second to second last. So this is the same structure. I will select the longest carbon chain. This will be 1, 2, 3, 4. So this is 3-methyl butanene. And 3-methyl butanene or butene we already do here. So these are the possible isomers which we can draw. Is it clear? This concept of the isomer, the structural and the geometrical? Any doubt in this? Question 9, any doubt? In question 9, after burning 0.9 gram of a methanol, the temperature for water increased by 16. The measurements uncertainty in the thermometer used in the experiment is zero point 0.5 for each reading. What is the percentage uncertainty in the temperature change? So, okay, about the last one, yes, I will clarify that. That's a good question. Like about the last one, the last question. Look, when you mention the isomer, because they ask us to, we have to include the structural, we have to include the structural and the stereoisomers both. Okay. So what are the structural isomer? One is pentene, another one is pentoene, another one is 2-methyl butene, then 3-methyl butene, and then 2-methyl butene. So how many structural? 1, 2, 3. So we have 1, 2, 3, 4, 5, and 6. So this is pentene, this is cis-pentoene or Z-pentoene or trans-pentoene. This will be 2-methyl butene, 3-methyl butene, and 2-methyl butene. So how many isomers are possible? 1, 2, 3, 4, 5, and 6 possibilities are there. That's why D will be the right answer. Don't count pentoene separate and then cis and trans. Not like that. Is it clear? Okay, after burning a 0.2 grams of a methanol, the temperature of a water increases by 16. The measurement uncertainty in the thermometers used in the experiment is 0.5 degree for each reading. What is the uncertainty in the temperature change? How a temperature change is calculated? It is the difference in the temperature. That's how we calculate it. So each reading has an uncertainty of 0.5. Like there's a uncertainty of 0.5 degrees in temperature 2, and there's an uncertainty of 0.5 in temperature 1. So what will be the total uncertainty in the temperature change? The total uncertainty in the temperature change will be 1 degree. Because uncertainty always add. Even we add or subtract the quantities, uncertainty always add up. If it was two different quantities, then we add the percentage uncertainty, but it's the same quantity temperature. And so if we need a change in temperature, we'll add the individual uncertainties. So 0.5 in each value. So means the total uncertainty in the temperature change will be 1. So what is the percentage uncertainty? The percentage uncertainty is the absolute uncertainty or uncertainty divided by value recorded into 100. So the total uncertainty will be 1 and the value recorded is 16 into 100. What's the answer for the percentage uncertainty? 6.3. So C will be the right answer. So why it become double? Because each reading was having an uncertainty of 0.5. So the total uncertainty in the temperature change will be 1 degrees. Any doubt in the second part B, C? Question 10. 9, part B as well. Okay. The student repeat the experiment but burned 0.3 grams of a methanol. The previous question. Uses 75 cm cube of water in a copper. What is expected here? You have to, what you have to do, you have to need the temperature change. Remember, look, if we double the mass, like we double it when 0.2 grams was burned and the volume which was used. So what is the expected temperature change? If we repeat the experiment, what is the expected temperature change? We increases the mass. Like example, when 0.2 grams was burned, the temperature change was 16 degrees. When 0.2 grams of the substance was burned, the temperature change was 16 degrees. When we burned 0.3 grams, how many times we have increased the mass? By what factor? By what factor the mass has been increased? So it is increased by 1.5 times. So if this is increased by 1.5 times, this should also increase by 1.5 times. And the volume, because the volume of a solution, okay, that part, actually, the volume of a solution also missed here. But how you will do such question? Let's take an example. We took here volume is 75, and let's a simple example. Originally, the volume was 50 cm cube of a water. Okay. So when we use 0.2 grams of the fuel and we use 50 cm cube of the water, the temperature change, let's say it was 16 degree. I'm just taking a random value because I miscopied that part. Like I couldn't miss the volume of the water should also be given in the first part. Now, if we 0.3 gram is burned, so means we have increased the combustion of the fuel, the mass of a fuel which is burned 1.5 times. So what should happen to the temperature change? The temperature change should also increase by 1.5 times. According to this one. So 16 into 1 and say the volume now we are using is 75 cm cube. If a volume we are increasing, by what factor the volume has increased? Or let's take, say it was 25. Just take a 25. So if it was 25, mass is not inversely proportional to temperature change. Mass is directly proportional to temperature change. If you burn more fuel, you will get more energy. When you use 0.2 grams of a methanol and you use 0.3 gram of a methanol, if you increase the mass of the fuel, the temperature change will also increase. But if you increase the volume of the solution, like first, the energy was absorbed by, let's say, 25 cm cube, and now the energy is absorbed by 75 cm cube. So 75 cm cube will have a smaller change in temperature. The formula E is equals to Cm delta T. This M is not the mass of the fuel. This M is actually the mass of the water which is used, or the volume of the water which is used. So if you use a large volume of the water, the temperature change will be half. This is not the mass of the substance which you are burning. This is the mass of the water or the solution you are using. And you consider the density of a water is 1 grams per centimeter cube. So if the mass of a combustion of the substance, the fuel is double or 1.5, this will also be 1.5. Same thing here. If originally, let's take the original volume was 25 cm cube and now you're using 75. So if the volume of the water is double or the mass of the water is double, what will happen to temperature change? The temperature change will decrease by 3 by the same factor. So in that case, it will be 16 multiplied by 1.5 divided by 3. So we'll get like, so this will be 8 degrees. So this is the mass of the water, or you can say volume of the water, and this is the mass of the fuel. So if I burn more fuel, the temperature change will also increase. But if I take a large quantity of the solution or a water, the temperature change will be less. That's the relation between the change in temperature and the volume or the mass of a water. But this is the mass of the fuel. Is it clear? This one? Because the original volume of a solution is missing, that's why you cannot solve the second part. Like you will not get the exact answer for the second part. Is it clear, the concept of the temperature change? Why we divided by 3? Because if you take a large volume of the water, as you can see, I'm just giving an example. If a 25 cm cube of a water, when it is supplied, say the temperature change is 16. But if you take a 75 cm cube of a water, if the amount of a water is like 3 times, the temperature change will decrease by 3. So the temperature change is inversely proportional to the mass of the solution or the volume of a solution used. But the temperature change is directly proportional to the energy given off or the number of the moles of a fuel we burn or the mass of the fuel we burn. If we burn a large amount of a fuel, in that case, the temperature change will also be higher. We don't have to guess the initial volume. As I mentioned, the initial volume is missing in the question. The first part of the question, maybe it's not copied. That's why you cannot solve the part B, because you need a volume of a solution to predict that temperature. The question is predicting a temperature. Because here it's written uses 75 cm cube of a water. So there will be some information about the volume of the water which was used initially. Question 10, any doubt? 10, 11? 12, 13, 14, any doubt? Which compound has intermolecular hydrogen bonding? Hydrogen bonding means hydrogen should directly bonded with nitrogen, fluorine or oxygen to have a hydrogen bond. So here hydrogen is bonded with oxygen. Here in CHO, the carbon is bonded with hydrogen and then hydrogen is there. So hydrogen is not directly bonded with oxygen. To have a hydrogen bond, hydrogen should have, like between the molecules, hydrogen should be bonded either with oxygen, nitrogen or fluorine. In this case also the hydrogen is bonded with carbon, and this one also nitrogen is bonded with carbon, and with a carbon the hydrogen is bonded. So hydrogen is not directly attached to nitrogen. That's why this can